So the next part is how do you determine the solubility product from solubility? For example, I have compound and that is lead sulfate. So what's the formula for lead sulfate? It has to be PbSO4. Okay, and this is a solid. Oh, this is a reversible reaction. So what do I get? I'll be getting lead and sulfate. Okay, so lead is a positive ion, and in fact, sulfate is also a positive ion. Okay, so once you get this, the next thing that we need to find out is what is the solubility product. For that, the answer would be K is equal to, so lead, that is Pb2 plus into or times the sulfate. So once this is done, now the question is the molar solubility. Okay, so mathematically, the molar solubility of lead sulfate would be or is equal to 1.40 times 10 to the power of minus 4 m, okay, of lead sulfate. That is the molar solubility of lead sulfate. So 1.40 into 10 to the power of minus 4. So how exactly this happens? Now, coming to the concentration part and lead sulfate itself, and only lead and again only sulfate. Because what happens here is 1 mole of lead and 1 mole of sulfate, when it forms, okay, I mean, again, when these two combine, what we get back is lead sulfate. Okay, so this, both lead and both sulfate, the value will be equal to 1.40 into 10 to the power of minus 4. So what can I say here is
Where did you
lead.
get the 1.40 times 10 to
That's
the
a
power?
basic value. It's given in your PPT.
Oh,
Haven't you
okay. So
seen
that
that?
is
Yeah, that's a constant value. That's not going to change. Okay. So these two, say your lead, for example, and sulfate, these two are always equal to 1.40 times 10 to the power of minus 4 m. That means lead has the same molecular value, molar value, and even sulfate will have the same molar value. So when these two combine, so then what would happen now? Because lead as well as sulfate have the same value. So now let me know what is true, not true. So this is again be confusing. What is 3 raised to the power of 2?
9.
How much is that?
6.
How?
Wait, isn't it? No, that's 9.
Exactly.
Yeah, I said
That
yeah.
is 9. 3 multiplied by 3 twice.
Yep.
Okay. So now, when I say the solubility product here, so I'm using the word product. Okay. So solubility product of both lead and sulfate. So that's going to be Pb2 plus times sulfate. So do both of them have the same values?
Yep.
Yeah. So how can I write these two now? So this can be written as 1.40 times 10 to the power of minus 4 whole to the power of 2 or raised to the power 2. Why raised to the power 2? Because lead and sulfate have got the same value.
Yep.
So when you times it or multiply it, instead of writing the multiplication twice, I can just raise it to the power of 2.
Yep.
Is that clear?
Yep.
Now, 1.40 is nothing but 1.4,
Yeah.
because the last term being or last number being 0 doesn't hold any value after the decimal. Okay. So
Yeah.
1.40 raised to the power 2 will again be 1.4 times 10 to the power minus 4 is also raised to the power of 2.
So times that again.
Yes. So 1.4 times 1.4 would be 1.96. 14 14s is 196.
Yeah.
So 1.4 times 1.4 would be 1.96. And
96.
10 to the power or 10 raised to the power of 4 times 10 to the 10 raised to the power of 4. So I'm going to put 10 as the base because that's a common base. And here the powers, which have been raised to the power of 4 minus 4, will now be added up.
So it'll be -8.
Negative 8. You got that?
Yep.
So this is how you find the solubility product of given substances.
So is that it?
Yes. So similarly, you have values for other substances as well. Okay. So maybe during your exam, you'll be provided with these values. Then they'll ask you to find out what? Solubility
Product.
constant or
Constant.
solubility product. Sorry. Okay. So now suppose if let's take another substance. Okay. What do we take? You have another substance like PbF2. So what is PbF2? You know what is Pb, right?
Yep. Lead.
What is P? P is lead. You know that. Okay. So what is PbF2?
F2.
Hmm.
That would.
What is F?
That'd be
What's only F?
Fluorine.
Fluoride. Okay. Yes. So now that could be lead fluoride. Okay.
Lead fluoride.
Lead fluoride. Exactly. So what's the
So
formula
that
for
would
lead
be
fluoride?
PB.
PbF2.
F2 to the
No, F2. That's
charge is
it. Yes.
-1.
No, it's only F2. So what would that mean? I have lead, which is one particular compound, one particular element here.
Yeah.
Okay. Plus, I even have fluorine with me. And fluorine is a negative ion. Okay.
Yeah.
So lead is in a solid state and fluorine, sorry, both are in aqueous states. I'm sorry. Lead is also in aqueous form and fluorine is also in aqueous form. Lead fluoride is in a solid form. So if I have to write the solubility product here, so how would that be? That would be Pb2 plus times
Times 2 fluorine
fluoride.
times.
Okay, understood this?
Yep.
Now, what can be done here is fluorine, because it is 2 here, we negate this actually. We can't write it as 2F. Okay, basically when you're writing the chemical equation, fine. You can mention this 2 over here, but here a big no. Understood? So then how do I mention this? The very easiest way to mention it is ion is a -1. Because there are 2 fluorines, I'm going to raise it to power of 2. Understood how it is written now?
Yep.
Now let us come to the molar solubility of lead fluoride. Okay. So what is said here is, if we have to calculate this, so how do I calculate? It's for the same formula again. So first of all, let us calculate for lead fluoride on the whole. Okay, so for this, it's going to be 0.064 grams of lead fluoride upon 100 ml of solution. Okay.
Yeah.
Now, because this is going to be calculated in terms of liters, we're going to use 1000 here. Okay, is that clear?
Yeah.
Yeah. Now what happens here is 2 zeros and 2 zeros can be struck off. So what is left is now 0.064 times 10. So when you multiply, the decimal moves one place to the right. Always remember.
Okay.
Because I'm multiplying with 10, the decimal will move one place to the right. What happens if I multiply it with 100?
Then it will move 2 places?
2 places. To which side?
To the right.
To the right. So the answer here would be, because it's going to move to the right, it's now going to be 0.64 grams per liter. Understood? Now, in
Yep.
division, now see, it's 0.064. If it is times 10, the decimal move to the right, okay? This
Yep.
was the answer. Now, if I had to divide, one second, let me go back. If I have to divide this by 10, now tell me whether this decimal would move to the right or to the left.
Sorry?
When you multiply, the decimal moves right.
Yep.
When you divide, it moves
Left. It'll go the
left.
opposite.
So then that would be 0.0064.
Yep.
Got it?
Yes.
So this sort of calculations will help you, further solving the problems. Okay. Next is for fluorine as well. Okay. So how do I do this? So how much of fluorine is to be used here? 245.2 grams. That actually is there in the question. Okay.
Okay.
He didn't put up the question in a proper way. So we'll just consider that to be 245.2. So that would now be 0.064 upon, that is grams per liter. Oh, one sec. What is the answer that we got here? 0.64.
0.0.
No,
There's no extra 0.
yes, 0.64. This is the answer that we got. Liters inverse upon 245.2 grams per molar. Now, if you see this, what he said here is, what's the answer given to us? Now, you can use your calci. What I want you to do is, do you have your calci handy there?
Yep.
Yes. So I want you to divide 0.64
Yep.
with 245.2.
245.2. That's 0.0026101114.
Okay. We need not go to that, the whole stretch of numbers. 2 places. Okay. So 0.0026.
Yep.
Okay. Understood that. Now, this, if I'm going to multiply with 1000, I'm going to get 2.6.
Yep.
Okay, because it is per liter. So it's into 1000.
Yeah.
Okay. And again, at the bottom we have into 1 by, one second. Let me put that here. So how much did we get there? 0.0026 times 1000 would be 2.6. Okay. Now, because it is grams per molecule, it is into 1 by 10 to the power of 3. Okay. So now what's going to happen here is, it's going to be 2.6 times, if I raise this 10 to the power of 3 to the numerator, if I'm going to take it up, that's going to be 10 to the power of minus 3. Always try to understand something.
Wait,
if I have
why?
a value, yeah, I'll tell you. According to the law of indices or law of exponents in mathematics, if I have something like 1 by a raised to the power of m,
Yep.
and if I take this to the numerator, power of positive m will now become power of negative m. So I'm changing its position from the denominator to the
No, as
numerator.
in, where did we get the
10 cube, because
Yeah.
this is still in grams, which is to be calculated in liters. So that's going to be into 1000. So 10 power 3 is 1000.
Oh, okay.
Okay, because it's still in liters.
Yeah.
So now the answer that we got here is 2.6 times 10 to the power of minus 3 m of what? Of lead fluoride. Is that clear?
Oh,
So how
yeah.
many values did we get here now? We got two values. One is 0.64 grams per liter. Using that, we found out the what do you say? The molar value of lead fluoride. Now
Yeah.
we'll have to go back to the question. In lead fluoride, how many atoms of lead and how many atoms of fluorine are present in it?
1 atom of lead and 2 atoms of fluorine.
That's correct. So 1 atom of lead and 1 atom of
Fluorine.
fluorine. So now if I have to calculate this, try to understand now. Okay, it's PbF2, which means it is, coming to the solubility product, it is Pb2 plus times. So how can I write this Pb2 plus now? So that's going to be 2.6 into 10 to the power of minus 3m. Done. Okay, this is for lead. Now, if I have to find out for fluorine as well, for fluorine, try to understand there are 2 atoms in it, not 1. So what I would preferably do here is I'll have to multiply this fluorine with 2. So that becomes 2 times 2.6 into 10 to the power of minus 3. So how much is 2 times 2.6? 2.6 and 2.6. 26 plus 26 is 52. That is 5.2. So 5.2 times 10 to the power of minus 3m. Got this? So now we have the values for lead as well as for fluorine.
So this would be the end values that we are trying to get. So we
No,
have to
still
go
not
through...
the end values, because these are individual values still.
Oh, okay.
Yeah, because let me go back to the previous question. If you see here, lead and sulfate both had the same values.
Yeah.
So basically, this would have been written like this: 1.40 into 10 to the power minus 4 times 1.40 into 10 to the power minus 4. Because they were of the same values, I had to raise it to the power of
2.
Got that now?
Yeah.
Here I don't have that option because the values are different, isn't it?
Yeah.
Lead has a different value. Fluorine has a different value here. So
Okay.
now I have to individually multiply them. So what would I do here now? If I have to find out the solubility product finally here, so how would I do that? So lead Pb2 plus times fluorine. But why did I put a 2 in the power here that is outside? Because there are 2 atoms of fluorine in lead fluoride.
Yeah.
Is that clear?
Yeah.
Okay, now coming to the next point now. So what is the value for lead that we got here already? 2.6 into 10 to the power of minus 3. Is this clear? This is the value of lead.
Yeah.
Times what now?
Times 5.
Fluorine. Times
Yeah,
fluorine
fluorine.
now. Okay. So what's the value for fluorine?
5.2 times 10 to the power of negative 3.
Negative 3. But what do we still have here?
Oh, and then times that by 2. So
Raised to the power
2?
of 2.
Yeah.
Okay. Now you need to find out these values. You have to multiply them and then find out. So one easiest way would be, I'm going to keep this 2.6 into 10 to the power of minus 3 as it is. I'm not going to disturb it. Now, you will help me to find out the value of 5.2. Because this is raised to the power of 2, it's 5.2 times 5.2. How much is that?
10.4?
No.
No?
Use your calci. No issues.
10.4.
No.
Oh, wait, am I doing
You're
the whole
supposed
thing?
to, yeah, times it, multiply.
Okay, just... .70, 10 to the power of negative 5.
No. How much is 5.2 times 5.2?
But
5.2 times 5.2 would be
27.04.
27.04. Isn't it?
Yes.
So it's 27.04 times, now 10 to the power of minus 3 times 2, because powers would get multiplied. Okay, so
Okay.
then that would be 10 to the power of minus 6.
Yep.
Is that understood?
Yes.
Okay. Now tell me, how much is 2.6 times 27.04?
2.6
Times 2.6.
times 27.04.
Yes.
That comes to not dollars, 70.304.
So 70.3 times 10 to the power of what?
10 to the power of
Here
9?
you have a minus 3, here you have a minus 6.
9?
So when you have both negative numbers, when you add them up, what would you get?
You just get the...
1 second. 10 to the power of minus 3 times 10 to the power of minus 6. Because the bases are same, the bases still remain the same. The minus 3 minus 6 would be 10 to the power of minus 9.
Okay,
Okay.
so it is.
Now,
Okay.
this is not the answer given there.
It isn't?
It isn't.
So did we
Okay.
do it wrong?
No, it is absolutely correct. Now here, the values are given directly.
Okay.
Okay, try to understand. They're given directly. And one more thing here is, even here, the 70.3 is actually been rounded off. So we didn't round it up. Now see what happens here. Let me divide this page.
So would our answer be more accurate than the one on the PowerPoint?
Exactly. Now it's going to be more or less the same. Now what I'm going to do here is, see, it's 10 to the power of minus 9.
Mm-hmm.
So I'm going to write it as 10 to the power of minus 8 and 10 to the power of minus 1. Okay, try to understand something here. So now 70.3 times 10 to the power of minus 8. If I take this 10 to the power of minus 1 down, it becomes 1 by 10 mathematically. Now, as I told you, if I'm going to divide, the decimal moves one place to the left. So this would be 7.03 into 10 to the power of minus 8.
Okay.
Now in your PPT it is given as 7.1. Now they didn't give us the extra decimals that were here. They must have been rounded off to the nearest values. Okay. So here we are a bit more accurate than what's that was an approximate answer. So this is how he has got the value of 10 to the power of minus 8 in the question. Because here, mathematically, as you keep multiplying, especially this part, you must be wondering, here we got a minus 3, minus 6, that becomes minus 9. Whereas in the question, he left it off at 10 to the power of minus 8. Okay.
Oh,
Now,
okay.
one more thing to note here is, you will not lose any marks in the examination even if you're leaving the sum at this point.
Is that the end point?
This could be the
70
end point as well.
Oh.
Now I'm that's what I'm trying to get as many lesser decimals as possible here. Now suppose if I pull down another one second. If I make this 7.03, I'm going to split this minus 8 as minus 7 and bring one of the tens down. Then this would be 0.703 into 10 to the power of minus 7. This and this are technically the same.
Oh, right. Okay. Yeah,
It's
no,
the
I
same
see
thing.
that.
Only
Yeah.
the decimals are moving one by one to the left.
Okay.
Okay. That's it.
So in the exam, even if I make it as 0.3, that answer is still more accurate. So they can't
It's
exactly.
technically correct. It is correct.
So then would this be the end point or would there be more to it?
No, that's up to you. Even you can leave it here as well. Want to go to this point? It's your choice.
No, as in like, would that be just the end of that whole calculation? So,
Yes, indeed. Yes, absolutely.
oh, okay. So to find the KSP, that is
Yes,
everything that needs to be done.
exactly. So most
Okay.
important things are these values. Okay. Because based on these values, you'll be getting the end answer.
Okay.
Okay.
Yeah.
Yeah.
Do you think you could send me questions or anything? Because the ones on our school PowerPoints, they were kind of made like 5 years ago, so they're not exactly the most accurate.
Okay. They're not the recent ones.
No. They're like
Okay.
they've been using the same slideshow for the past 6 years.
Okay. So they've gone ancient now.
Yep.
Yeah.
They only use those slideshows only for the theory based, and then they do their own.
Okay. Fine. So I'll try to give you a few sums based on the same theory.
And
Okay.
then I
Just
can
give me
just
a
send you
minute.
photos of them if you want.
Yes.
And then there was one more thing that
Mm-hmm.
our
Yes.
teacher, let me find it.
Mm-hmm.
It was common ion effect.
Okay. Yes.
I don't really know what that is. And also, do you know on the PPT how it has the ice table? Well, what they call the ice table at least.
Yes. Is it there in this PPT?
Yeah, on the solubility, it's like on page slide 12
Slide 12.
on the solubility one.
Okay.
Solubility equivalent.
One sec. Are you talking about this one?
Yes,
Is it
so
this
that
one?
one.
Yes. Yes.
So
Yes.
is there like what we've done and what this is it the same thing?
Absolutely.
So
You
is this
need not make this table. Did they ask you to make this table?
no, they're just trying to teach us it. They're like, oh, if like it might be a bit easier. I'm not sure.
Okay. Okay. Okay.
I don't really I can't understand the calculation, so I couldn't tell.
Okay. But you understood what I explained
Yep.
just now. Okay. That's a bit easier way of even
Yeah.
understanding this.
And then do you know how it
So.
says like equilibrium and the constant? Like
Mm-hmm.
what what would it mean?
I'll come to that. I'm just trying to pick out a sum for you. Uh, okay. 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 I got something for you here. Mm,
Oh, I can send you the workbook as well. We have this one workbook, but it's
okay.
like 200 pages long, so you might have to
Oh.
it's like with all of like the topics.
Okay.
So it has all just questions and answers.
Mm-hmm.
So I'll just email you that as well.
Fine. So here's a question for you. Okay.
Yep.
Let us try. Times 10 to the power of minus 10. Okay. So will you be able to find the solubility product?
Yes, if
Yes.
I
Come
go
on, let's
through the
try.
same steps.
Let's see.
So first, it would be writing down the equation. So
Mhm.
CaF2 with one of the arrows. Is that a solid?
Yes,
Or
it is solid. Everything is solid. Fluorine is a gas, in fact.
yeah. So then it would be Ca and carbon
No, calcium
is
fluoride. Ca
calcium.
is calcium. F is
Calcium.
fluorine, so it becomes calcium fluoride.
Yep. So then that would be Ca2 plus.
Mm-hmm. Correct.
2 plus fluoride, which is -1. So that'll just be a
2F,
negative.
2F negative.
2F negative
Yes.
because there's two of them. You're right. And then K equals in square brackets Ca2 plus,
Yes.
and then in square brackets again. Now it will be F minus outside brackets to the power of 2.
Correct.
And then from here, it would be CaF2 equals it would be
So Ca, it would be 1.08 times 10 to the power of minus 10.
so
This will
is
not
that
change.
okay? So that's
What
already
about
given.
fluorine? Yes. This would be 1.08 into 10 to the power of minus 10 raised to the power of 2.
Okay, and then because in the previous question
No,
in
it's times 2, not
slide we
raised to the
got
power of 2. Sorry, sorry. Because it is 2F, right?
yep.
Yes.
No, in the lead fluoride we got 0.064 grams, and then that's where we had to
No, you
go.
need not go to that part now. We directly have to find the solubility. We actually have found out this here. I mean, the solubility value for it. You only need to find the product for this now.
Okay.
Yeah.
So then F2 equals 2 brackets 1.08 times 10 to the power of -10. And I'm guessing I just put that in the calculator.
Mm.
Which gives me equals 2.16 times 10 to the power of -10.
Mhm.
And then is that it?
Exactly.
And then is that just moles?
Hmm. So next, what you need to do here is the solubility product would be Ca times F. So calcium would be 1.08 into 10 to the power of minus 10 times 2.16 into 10 to the power of minus 10 raised to the power of 2. So now one more step. 1.08 into 10 to the power of minus 10. So now you have to find out how much is 2.16 times 2.16.
2.16 times 2.16.
Yes.
4.6656. So
So
4.6.
that would be 4.7 as well.
Oh,
Now you
right,
must be
yeah.
wondering how?
Because
Because
of
4.66. Here we have a 5 and the next decimal is more than 5. So I can round this off to 6. So now because it is more than 5, this would become 4.67. And because we have a 7 after 6, this would be 4.7. So I've just rounded it off. Okay.
Okay.
Times 10 to the power of minus 10 times 2 would be minus 20. Okay.
Yep.
Now you need to find out by multiplying 1.08 times 4.7. Multiply these two values. Let me know what the answer is.
1.08 times 4.7 comes to 5.076, so 5.1.
5.076 times 10 to the power of minus 10 minus 20 would
10
now
to
be
the
minus
power of
30. Because both are negative, we need to add them off. Okay.
Yeah.
Now, can I change this to 5.1? Yes.
Yeah.
Because it is 6, the 7 becomes an 8. And this is 0. We have a 7, 8 after that. So it's technically like this 5.076. It becomes 5.08. I can now write this as 5.1. So it's basically 5.1 times 10 to the power of minus 30. I think you got the hold of this now.
Okay. I will practice some more on that worksheet.
Exactly.
But yeah, I think, yeah, okay. That makes sense. So you have to figure first. So in the PB, in the lead fluoride, you know how it said there's how we did the 0.064 grams over 100 mils and stuff like that? How come we didn't do that here?
Now here, you first, in this lead fluoride sum, you first had to find out its molar value.
Oh, because
Here
the
in the
molar
sum what,
value is
yeah,
given.
in the sum what I gave you, I already gave you the molar value.
Okay.
Understood?
Yep. So when molar value isn't given, that's when you have to do all of that
Then
through
yes, then the
random.
weight, yeah, then the weight will be given to you. Then you have to find out these calculations as well to get that answer separately for both lead and fluorine. Okay, we'll do few sums on that as well tomorrow. Okay,
Okay.
but right now today I would maybe in an. Do we have time today, or we're done for the day?
No, I have time today.
If you do
I'm not
not,
going anywhere.
okay. So even if in the morning, probably if you can just find out some time. So try sums as we have done these now. Which ones? Kind of like this.
Okay. So
Okay.
more like the ones that molar
Yes.
value is already
Yeah.
given.
Given the molar value, yes.
Okay.
So first try to get a hold of this. Then I
So
even
that
will
one's the
just put
easy
you on
one, and
sums.
then without the molar value, that's the hard one.
Yes. Yes. So let me check in your PPT if you have any sums given here.
And then tomorrow, do you think we could also cover the other, the what was it? Common ion effect?
Okay. In which PPT is that?
She said it was on the section in the solubility PowerPoint.
Okay, the same one which I showed you
Yeah,
a while ago.
yeah, apparently it's
Yes. Okay, calculating the effect of a common ion on solubility. Wait, let me share that. Are you talking about this one?
yeah.
Yes, for sure.
Oh my god, that's a lot of
The
math.
ion product expression?
Yes. Our teacher wasn't here. She just told us to look through it. That's all.
Well, I'll be explaining this tomorrow. Okay?
That'll be fine.
Yeah, fine.
And then I'll just let you know what time tomorrow, because if I'm going to the restaurant, then I will definitely take the morning class.
Okay. So, but when will I get to know this?
Probably in like 20 minutes.
That's great. So,
Okay.
what I mean to say is, before I go to bed, if I know that you're going to take a class in the morning, that would be great.
I will tell
Okay.
you in 20 minutes.
Yeah, sure. Okay, Miss
Okay.
Khan. Fine.
Thank
Fine.
you. Bye.
You're welcome. Bye bye. Take care.